Hello, my name is Nicholas Bork, and this is the second question for the Quality Improvement class project. So, as you can see here, this is question 2 from the class project. It is asking us to review this table, and part A says to determine the capability of the process regarding the indicated dimension, with the specs being 10.7 plus or minus 0.15. And part B asks us to provide the non-conforming percentage, so the percentage of defective parts. Just like question 1, the first step is going to be input all the sample data, which I've already done to save time, into Excel. Now, we can work on part A. So, to determine the process capability, we're going to be using a CPK method, which is going to tell us the actual capability of the process, as opposed to a regular CP method, which would only tell us the potential capability. So again, we're going to use the CPK method, which is going to show us the actual capability. So our second step is going to be to find the average of all of our sample data. So to do that, we can do the average function in Excel. We can select all of our data, and there's our average. And we're going to take away some decimal points just to clean it up. Next, we're going to want to find our standard deviation. And again, we can use the Excel formula, standard dev dot, and we want to use .s here because this is a sample. We don't want to use .p. This is not a population, this is a sample. And again, we can select all of our sample data here. And here is our standard deviation. Next, we want to find the upper specification limit and the lower specification limit. Now to do that, we're going to take the average spec, which is 10.7, and to find the upper specification limit, we're going to add 0.15 to it. So it's going to be this plus that, which again is found in the problem here on the indicated dimensions. Now for our lower specification limit, we're going to do the same thing, but we're going to subtract that 0.15. Now that we have found all of our needed numbers, we're going to work on calculating the CPK. And to do that, we're going to calculate the CPU and the CPL, which is the upper capability index and the lower capability index. So to find the upper capability index, it is the upper specification limit that we calculated down here, minus the average, which we calculated here, divided by 3 times the standard deviation. Again, it's going to be our upper specification limit minus our average. And that's going to all be divided by 3 times our standard deviation. And we're going to get 0.58885, which we can lower a decimal point here. We're also going to find the CPL, which is, to find the CPL, the formula is the mean minus the lower specification limit divided by 3 times the standard deviation. So again, we're going to take our mean, or our average, and we're going to minus the lower specification limit that we calculated here. Now we're going to divide all of that by 3 times our standard deviation. we're going to get 0.572717. We're going to clean this up a little bit. So when you're looking at process capability, you're going to look at the lowest result between CPU and CPL. And that's going to be what you base your process capability on. Now, the biggest thing here is that for a process to be capable, a CPU or CPL must be greater than 1. Now, a process is incapable if our CPU or CPL is less than 1. As you can see here, our lowest number is our CPL, and that is 0.573. Now, as you can see, 0.573 is less than 1. This means that our process is incapable. Okay, so now that we have determined the capability of the process, let's provide the non-conforming percentage. Now, to do this, we're going to use z-tables to find the non-conforming percentage. So we're going to find the first z-table using the lower specification limit, and the second z-table using the upper specification limit. So to find z1, the formula is the lower specification limit minus the average, or x bar, divided by the standard deviation. Again, it is the lower specification limit minus your average divided by your standard deviation. We're going to get negative 1.72. I'm going to get negative 1.72. For Z2, very similar here. We're going to do the upper specification limit minus the x bar, or the average, divided by the standard deviation. So for the upper specification limit, or sorry, for Z2, you're going to take the upper specification limit, going to subtract x bar or the average, and you're going to divide it by the standard deviation, and this gives us 1.77. So from here, you're going to want to use the z-table, which is referenced in Canvas. You want to find both of these values and find the correlating z value on the table. So for negative 1.72, I would pull up the z-table, but unfortunately it will stop the recording if I close Excel. So you're going to have to trust me. You're given a value of 0. Let me reference my notes. 0.0427. And here you're given a value of 0.9616. Now you may be thinking, what does that mean? So for your Z1, using your lower specification limit, 0.0427. This means that 4.0 27% of your data lies below your lower specification limit, aka it is out of the 3 sigmas. So it is stuff that does not conform. Now your Z2, using your upper specification limit, is showing that 96.16% of items are under your upper specification limit. Now that's great, but we want what's over the upper specification limit so we can know what's outside of the 3 sigma mark to see what does not conform to our specifications. So to do that, we're simply going to do 1 minus this Z value and we're going to get 3.84%. Now this is the 2 percentages that lie outside of your specification limits, which means the non-conforming items would fall into these categories. So it asks us to provide the non-conforming percentage. What is a percent of defective parts? Here you can see if we add up these 2 percentages, we get 8.11%. So our total non-conforming percentage for this data is 8.11%. And that covers both part A and part B. Thank you very much for watching.